All right, so our controller mapping is pretty much done for now, but there's one more thing I wanted to cover, and that is the C# concept of enums. Now, we haven't seen many enums in use throughout the Unity API, and we probably won't be using them that much for the remainder of this course, but enums are pretty simple to understand. It's a foundational concept of C#, so we might as well get familiar with this concept. Now, there's a particular place that we've seen enums in our code and kind of ignored it up until this point, and that is with the input class methods. The getKey method, for example, has two overloads. So for example, if we look at the overloads here, one is for a key code, the other one is for a string. So what's a key code? We hover over it and it says an enum, right? So when we right click this and go to definition, right, here's an enum, right? It's rather large because this handles pretty much any type of typical button input for a keyboard. So as you may notice here, an enum is sort of like a very narrowly defined type, sort of like a really, really simple class that's comprised of just a sequence of named constants that are separated by commas. So what's the use of enums? Why not just use strings for names, right? Well, enums are preferable to strings in that they can't be mistyped as strings can, right? We just pretty much dealt with that with the input manager where we had to remember the name of our axis. And not only do we have to remember it, but strings can fail silently, right? They don't give you an error if you type in the wrong string, not always, unless it's coded that way, right? So if you don't have an explicit error for key inputs, for example, then you have to basically guess at whether or not you're using the right name, right? It could be ambiguously labeled. You could guess the string value of an obvious key, like, for example, P or Q, right? You just imagine that there would be P or Q. But what about the enter key? Is it enter in quotes or is it return in quotes, for example? I mean, I don't know. And that's why enums come to the rescue here. Why leave it up to a guessing game? Why not just use its named constant instead, which you can easily look up with IntelliSense? So using IntelliSense as our guide, we just type in key code, and then if we suspect it's enter, I'm going to hit E, and there is no enter, right? So hitting R for return, there it is, return key, right? So it's just that much easier using named constants to constrain the list of possibilities for the end user, for the consumer of the code. All right, you may have noticed that there's these integer values beside each key code in the definition. You could reference the numerical value instead of the actual named constant, and this sometimes has its advantages, but under normal conditions, you're going to want to use the named constant. In the definition, if you don't explicitly assign the numerical value, it assumes a numerical value based on the item's order in the enum, starting from 0. So just to demonstrate now how all this works with enums, fire up a test script and create our own enum. So here in scripts tests, call this enums. And go to our main scene. And on the test game object, attach that. So we'll say public enum, we'll say player states, and this enum will be comprised as follows: idle, walking, running, attacking, defending, jumping, and falling. So these are all common states in a typical game, especially a platformer, right? Now here, we can give this class an enum by referencing it like this. So we'll create a field to hold those player states, right? we'll say player state because it can only hold one state at a time, which we'll talk about more in a second. And just to flesh this out more, I'll say int move speed. This is not an example we're actually going to use in this project. I'm just showing you how this all works by way of analogy. So in start, we can say move speed equals 0, say. And, well, we'll start off our starting state, let's say, is idle. So we access the named constant by going through the enum, and then there's our list of possible named constants, and we'll say idle. And then an update, you can imagine a state keeping scenario using enum such as this. If player state is equivalent to player states dot running, I'll say move speed equals 2, else if player state equals player states dot walking, move speed equals 1, else move speed equals 0. And for consistency's sake, I want to rename these. Say player state with a capital S, and just rename them all. All right, and yeah, of course, you can, as I said earlier, you can, instead of using the name constant, you can just use the numerical value. So this would be indexed at 0. So if you hover over it, it'll tell you its numerical value. So if player state equals 0, that would refer to idle as well as a possible enum state, right? All right, but what I wanted you to notice was how you can use enums for state holding in much the same way that we've been using bools for much simpler state holding, things that you're either in a true or false state. And so you can use an enum somewhere in your code where you can determine whether or not the state is walking, running, attacking, and so on. And the rest of your code can sort of look at that as a summary of what state you're in and not worry about the underlying code that determines that state. And with that, you can then determine some other behaviors, right? Again, it's sort of like the bool that we used for is powered, except it's a lot simpler, the bool is. So whereas a bool can only hold one of two possible states, on or off, an enum can hold any number of possible states that are predefined in the enum itself. So the analogy I always think of is a bool is like a light switch or light bulb. It can be either on or off, right? One of two possible states. Whereas an enum is more like one of those multi-speed blenders, right? Where you can be in any state of multiple states, but as soon as you switch to one of those states, it switches off whatever previous state it held, right? So only one button can be pressed down at a time and the other buttons pop right back up, right? So one goes to on, the others go to off. That's kind of how enums work, and wherever you have a state holding mechanic in your game that resembles that, an enum would be a good choice. So enums are great when you need name constants to prevent mistyped information, as well as holding state, similar to bools. And they're really simple to create and use. So really there's no reason not to use them whenever these scenarios pop up. All right, in our project, we could have used an enum at some point. A good example probably would have been a custom input class that sort of acts as an interface between the Unity input manager and the rest of your code. So, you could accept the user input and then convert it to an enum state of sorts that then the rest of your code references in order to determine its behavior, right? But our game is, pretty simple, and I don't really want to clutter it up and make it any more difficult than it needs to. But at the same time, I want you to be aware of enums and that the options available to you. All right, so that's all I want to say about enums. I'll see you in the next lesson.